Welcome to this session about how we describe Kafka security in AsyncAPI. My name is Dale, I'm a developer for IBM, and I'm a new member of the AsyncAPI Technical Steering Committee. When I say security, there are two aspects I'm including in this. Encryption, are you using SSL TLS for your connections to Kafka? And authentication, do you need credentials for your connections to Kafka? And I'm going to cover this in both directions. Firstly, writing an async API document. What I mean is, how do you go from a configured Kafka cluster to writing an async API document that describes it? And secondly, using an async API document. So by that I mean, how do you use an async API document to configure a Kafka client application? But like I say, let's start with how do we go from a configured Kafka cluster to writing an async API document that describes it? As I said, I'm going to cover both encryption and auth, but first let's start with encryption. We describe this in the server protocol section of the document. So if your cluster isn't set up to use encryption, then you just use protocol Kafka. If your cluster is set up to require encrypted connections, then use the protocol Kafka Secure. So no encryption, use protocol Kafka. Encryption, use protocol Kafka Secure. So that's encryption sorted. Next, let's look at how we describe the authentication setup. If your cluster is set up so there's no need for authentication, that's easy. You just describe the server like this. If authentication is required, then you need to add a security section to the server definition. And then the presence of the security value is what's telling you that authentication is needed. The type value in the matching security scheme tells you the authentication mechanism. These are the security scheme types in AsyncAPI that you can use with Kafka. Plain for SASL plain, Scram-SHA for SASL Scram in both the 256 and 512 variants, OAuth2 for OAuth bearer, GSS API for Kerberos, and X509 for mutual TLS. Let's look at a few examples of what this will look like. So, if your Kafka cluster is set up without encryption, but using SASL plain for authentication, you would describe it like this, using the protocol Kafka and the security scheme type plain. Or, if your Kafka cluster is set up to require encryption and using SASL Scram 256 for authentication, you would describe it like this, using the protocol Kafka Secure and the security scheme type Scram-SHA 256. One last example. If your Kafka cluster is set up not requiring encryption, but using SASL Scram 512 for authentication, you would describe it like this, using the protocol Kafka and the security scheme type Scram-SHA 512. So that's how you write an async API document that describes your Kafka security. Next, let's look at this the other way around. How do you use an async API document to configure a Kafka client application? I'm going to go through a few examples, and for each one I'll show you a couple of different ways of configuring a Kafka client app. Firstly, values in a properties file, and that's the most common way of configuring a Kafka app. And secondly, I'll show you how to do it programmatically using Java as an example. So let's start with the simplest document, protocol Kafka. So remember that means no encryption, and no security scheme. So remember that means no authentication either. So you'd configure your app for this using security protocol set to plain text. And in Java, it could look like this. You would put your security protocol config set to plain text in the properties object that you'll pass to your Kafka app. Let's try another example. In this one, protocol is again just Kafka. So again, that means no encryption. But this time there is a security scheme, so that means we are using authentication, and the security scheme type tells us the SASL Scram mechanism we need to use. So the security protocol we would use in our app this time is SASL plaintext. The plaintext bit is because there's no encryption, and the SASL bit is because we're using auth. And then the SASL mechanism identifies the auth type. And in code, in using Java as an example, it would look like this. SASL plaintext for the security protocol config, and Scram-SHA 256 for the SASL mechanism. Let's try one last example. In this one, the protocol is Kafka Secure. So remember that means encryption, and there is a security scheme, so that means there's also authentication, and the security scheme type is telling us which SASL Scram mechanism to use. The security protocol we would use in an application for this is SASL SSL. the SSL bit because there is encryption, and the SASL bit because we're using auth. And then the SASL mechanism identifies the auth type. And in code, it would look like this. Again, SASL SSL for the security protocol, and scram SHA-512 for the SASL mechanism. So hopefully you get the idea. The server protocol and the security scheme type tells you everything you need to be able to configure a Kafka client application, everything except the credentials themselves. And to sum up, here is the full list of all the possible server protocol and security scheme type values, together with the corresponding Kafka config properties. There are some blank cells here, so these are where you don't need to set a value. So for example, if there isn't a security scheme type in your AsyncAPI document, that means you don't need to set security.protocol in your Kafka client application. There are a few tools that I'm aware of that understand what I've gone through. So if you use the AG, the AsyncAPI generator, it can generate Markdown, HTML or Java code with the right Kafka config based on what is in your AsyncAPI document. The URL for the plain vanilla Java template, it's a bit different because this is a new template that we just created for the hackathon, and we're still in the process of contributing it to the AsyncAPI org. Other than that, it works just the same as the others, and I expect this is going to be moving pretty soon. And if you use the Node-RED AsyncAPI plugin, that will configure security for Kafka nodes in the same way that I've been describing. So, thank you for listening, and I hope this was helpful.